Finally, we are starting with the biggest chapter of class 10th mathematics, triangles. And the only, and not the only, but yeah, there are very few chapters of geometry in your mathematics syllabus in class 10th. So this is one of the biggest chapter of geometry in class 10th mathematics syllabus. So I have planned to do this chapter in a proper way. Let me just talk to you about it first and then start it so you have a proper idea that how I'm going to cover this chapter. Okay, so see, I'm going to divide the whole chapter in 4 parts. Okay, so there are going to be 4 parts, 1, 2, 3, and 4 parts. The first part will be of theorems. Okay, in the theorems I'm going to complete BPT or Thales theorem, which is basic proportionality theorem. Okay, then I'm going to yeah, of course, converse of basic proportionality is included with it, and some more results on basic proportionality theorem. After that, I'm going to cover similarity of triangles, the theorems based on similarity, the tests of similarity of triangles. After that, I'm going to complete uh, relationship between the ratio of areas of similar triangles and the sides of similar triangles. So I'll call it ratio of areas of similar triangles. And there are many other theorems with these theorems which I'm going to cover, namely angle bisector theorem, that is angle bisector of the interior angle and angle bisector of exterior angle. So these theorems will also be done in the first class, that is today's class. In the second class, will also be about theorems. The second video of this chapter will also be about theorems, but in that I'm going to focus on only one major topic of this chapter, that is Pythagoras theorem, the proof of Pythagoras theorem and its converse, I'm sorry, not inverse, converse of Pythagoras theorem. Then some, very famous result based on Pythagoras theorems. There are 3 or 4 more results which we are going to do before we start doing or solving some questions. Okay, so for that I'm going to make a separate video. In the third video, I'm going to do solved examples based on the theorems which are going to be done in today's video, that is these all theorems. The solved examples will be done in the third video, and in the final video, that is the fourth video, again I'm going to do the solved examples, but from which part? From the Pythagoras part only. Okay, so from you can say that the theorems based on Pythagoras theorem and its converse and more results, the examples which are based on that will be done in the fourth part. Okay, so this is how I'm going to cover the whole chapter, and of course you are going to learn many more things which you have not learned in your school, because they have reduced some syllabus and they've cut out some topics. I'm not going to reduce anything. I have to do the full chapter, so you are going to learn the full chapter triangles in my videos. Okay, so and why I selected this method, why I'm doing theorems first, because you get a proper idea about what we are going to study, and then to apply the theorems becomes very easy, because we have already proved the theorem wherever necessary. Like, out of all these theorems, we are not going to prove every theorem. BPT we are going to prove, the converse of BPT we are going to prove, some more results based on BPT we are going to derive, right? Some other theorems are also we are going to prove, but similarity of triangles we are not going to prove. They are just to be understood. They are just for our understanding. Okay, so theorems, all theorems are not needed to be proved. Whichever are needed to be proved, we will prove that. and in the videos following it we will do its example. So what we can do is we can make the first video based on these theorems, and the second video make based on the solved examples concerning these theorems, and then the third video will follow, which will cover Pythagoras theorem, and the last video will have solved examples based on Pythagoras theorem. We can sequence it like that, and I will try to finish the chapter. Although it's a huge chapter, it's a big chapter, but I'll try to finish it in as many less number of parts as I can, so that it's not a heavy burden on you. So yeah, of course the videos are going to be little lengthier, little longer, because the content, the topic of this particular chapter are not very straightforward or simple. So to understand everything properly, we might need some time. Okay, so in order to get some proper time, videos might be a little longer, so please adjust with that. Okay, let's start. Let's begin. Okay, before beginning, I would also like you to have your pens and your notebooks ready with you. Also your scales and pencils, because you might have to draw the diagrams. You have to write. You compulsorily have to prove all the theorems while watching the video with me. Okay, so when I tell you to pause the video and solve the theorem, or write the theorem, or you can say prove the theorem, you have to do it while watching the video. So that is compulsory. Okay, it is not optional. You have to write or prove all the theorems and memorize the statements of the theorem, because they are to be used while solving the examples. Okay, so without any further delay, now I think we are ready to begin with the chapter. Now, in the introduction of this chapter, uh, we separate the ideas of similarity and congruency. The congruent figures are having same shape and same size, but similar figures have same shape but different sizes. They are known as similar figures. Okay, congruent figures are alike in all aspects. Their shape and size all are equal, but similar figures are not alike in all aspects. Similar figures are not alike in all aspects. Similar figure have same shape, but they have different sizes. Same shape, but different sizes. Okay. Two congruent figures are always similar, but two similar figures need not be congruent. Always understand that. So to prove my point, I would like to draw a figure and then show you that what is the difference between congruency and similarity. A, B, C, P, Q, R. Now as you can see, both these triangles, they are not of the same size, but yeah, they are of the same shape. Okay, PQR triangle is bigger than triangle ABC. So these are the examples of similar triangles. These are the examples of similar triangles. Now if I would draw another triangle which is exactly same in size and shape, let me just copy paste it. Okay, and let me give it another name. Okay, let me give it a name X, Y, Z. So ABC and XYZ, they are having same shape and size. They are having same shape and size, ABC and XYZ. So ABC and XYZ, these both triangles are said to be congruent triangles. These two triangles are the examples of congruent triangles. Okay, same shape and same size. But are they similar also? Yes, they are similar also. So congruent triangles as well as similar triangles. Congruent triangles are also similar to each other. But similar triangles are not congruent. Remember that. Because for congruency, two shapes should be alike in all aspects. Two geometrical figures should have same shape as well as same size. So ABC and PQR are similar but not congruent, but ABC and XYZ are congruent as well as similar. Okay, so I hope that now you know what is similarity. The word similarity itself says that they are equal but not completely equal. Okay, they are alike but not completely equal. Okay, now which are the examples of two similar figures? Similarity can always exist between any two line segments. Two line segments are always similar. Two circles are always similar. Two squares are always similar. See, because two line segments, two circles, two squares, they may have uh, same size, but they always have same shape. Their shape, their dimensions are always dimension as in uh, the shape, not the measurement. Okay, their shape is always same, but their measurement can be different from each other. That's why these figures are always similar. Even two equilateral triangles, both equilateral triangle will have all the angles equal to how many degrees? 60 degrees, right? So their shape becomes the same, but yeah, their size can be different. Their sides length can be different. That's why they are not congruent. They are similar, and they are always similar. Any two equilateral triangle or square or circle or lines, they are always similar. Okay, so what is similarity? In similarity, always remember we are going to study similarity in detail. But before we take on this topic of similarity in detail, you must remember few things. Two polygons. Now they are saying two polygons. What is a polygon? Polygon is a closed figure bounded by straight line segments. Okay, so triangle is the polygon with smallest number of sides. There cannot be any other polygon with lesser number of sides than triangle. Triangle has three sides. Can there be a polygon with two sides? No, because it should be a closed figure, so it must have at least minimum three sides. So any polygon like triangle or quadrilateral or pentagon with the same number of sides is said to be similar if the corresponding angles are equal. See the uh, criteria for similarity they are telling. Corresponding angles must be equal, and and the length of their corresponding sides must be proportional. The length of the corresponding sides must be proportional and corresponding angles must be equal. Only then uh, these polygons are said to be similar. And we are not going to talk about any polygons. We are going to talk about specific polygons in this chapter, that is triangles. The name of the chapter itself is triangles, right? So this, the symbol for similarity is this. It is this. Okay, in previous class you have studied about congruency. So congruency had an equality sign underneath uh, this S, which is the symbol for just similarity. So this is congruency, but if you remove the two lines, it becomes the symbol of similarity. Okay, so let's begin. Okay, I think we have more definitions to go before we officially start with our theorems. Now similar triangles, uh, two triangles are said to be similar, I just told you, when their corresponding angles are equal and corresponding sides are proportional. Now what do you mean by corresponding angles? Now those who have studied congruency in detail with carefully, okay, they understand the meaning of corresponding angles. Corresponding angles are those angles. Corresponding angles are those angles which lie in, you can say, the, you can say, what what word should I use, complementary positions to each other in both the figures. That is corresponding positions or complementary positions. So in both the figures, the position of point B and the position of point E are corresponding to each other. Okay, the position of point C and the position of point F are corresponding to each other. The position of point A and position of point D are corresponding to each other. So angle A is equal to angle D are corresponding angles. Angle B is equal to angle E are corresponding angles. Angle C is equal to angle F are corresponding angles. So when two triangles are similar, their corresponding angles are always equal. And what about their corresponding sides? So the corresponding sides must be proportional. What do you mean by corresponding sides being proportional? That means the ratio of AB and DE must be equal to the ratio of BC and EF, must be equal to the ratio of AC and DF. So suppose AB is let's say 2 centimeter, DE is 6 centimeter. What is the ratio? 1 is to 3. Okay, BC, let's say 3 centimeter, EF is 9 centimeter. What is the ratio? 1 is to 3. AC, let's say it is 4 centimeter and DF is 12 centimeter. What is the ratio of AC and DF? 1 is to 3. So all the corresponding sides ratio are equal. That means both the triangles are similar. All the corresponding angles must be equal and all the corresponding sides must be proportional. That means both the triangles are similar. Now there is one more figure which they are, one more term which they are using over here, that is equiangular triangles. Equiangular triangles. Two triangles are said to be equiangular if their corresponding angles are equal. Two triangles are said to be equiangular if their corresponding angles are equal. If the corresponding angles of two triangles are equal, they are said to be equiangular. Now, if the corresponding angles are equal, will they be similar or not? Yes, they will be similar. So learn this thing, understand this thing and learn this thing, that equiangular triangles are always similar. So whenever they use the word equiangular triangle, you will read it as similar triangles. No question asked. If the angles, corresponding angles of two triangles are equal, then they are equiangular or similar triangles. Okay, so that's also a term which they are going to use often. Now you have an idea about what is similarity and what is similar triangles, and when they are similar, when they can be called as similar triangles. Okay, now let's start with the theorems. So the first theorem is basic proportionality theorem or Thales theorem. Okay, this is a very important theorem. This theorem has been asked in your board exams many number of times. Remember that. This theorem has been asked in the board exams for proving. So what they say is, prove that. I will read the statement, but I will read it in a question format, how it is asked in your uh, examination. In the question format, this theorem is asked as, prove that if a line is drawn parallel to one side of triangle, prove that if a line is drawn parallel to one side of triangle, intersecting the other two sides, then the other two sides are divided in the same ratio. This is the statement of basic proportionality theorem. Basic proportionality theorem is also known as BPT. So many students, they ask me that whether we should write BPT. Is it advisable to write BPT in exams, or we should write basic proportionality theorem, or we should write Thales theorem? See, according to me, BPT is allowed. You can write BPT, like you can write AAS or SSS. Similarly, you can write BPT, like you write CPCT. You know what is CPCT? CPCT is corresponding parts of congruent triangles. You used to use it a lot in class 9th. So if you can write those terms in short form, why not BPT? Of course. But again, this discretion is with your school authorities, your school teacher. Because according to the board's rules, she or he might be able to suggest you exactly that what is allowed. So some protocols like this, these are very trivial protocols. If you ask me personally, I don't mind. If you write BPT, I will consider that you have the knowledge and I will give you marks. But schools always follow some protocols, some rules. So we have to abide by those rules. We have to follow those rules. You cannot argue over there that no, my sir told me that BPT can be written, so I will write BPT. No, you cannot argue. If they are saying that no, BPT is not allowed, you have to write the full name, basic proportionality theorem or Thales theorem, then you write accordingly. Don't argue with them. Okay, don't argue with your school teacher, because they have to follow some protocols, and so do you. Okay, so what is this theorem? This theorem says that if a line is drawn parallel to one side of triangle, I will draw another figure over here and explain, because the given figure in the question has already got some construction which might confuse you. So I will give it a name A, B, C. So in this triangle, if a line is drawn parallel to one side of triangle, okay, so line is drawn parallel to one side. So suppose line is PQ and PQ is parallel to BC. Then, intersecting the other two sides in these 2 points, P and Q, then the other two sides are divided in the same ratio. Now, PQ is parallel to BC. Which are the other two sides? AB and AC. AB and AC are divided in the same ratio. That means AB and AC are divided proportionally. That means AP upon PB. See, they have written it as D and E. I have written it as P and Q. That's why the name difference. But doesn't matter. The meaning is same. AP upon PB is equal to AQ upon QC. That is the case. That should be the case. But since we have not proved it, so we cannot apply BPT until and unless we prove it once. Right? So we have to learn how to prove this thing, that if a line is drawn parallel to one side of a triangle, it divides the other two sides proportionally in the same ratio. Okay, so we have written given. Please, when I tell you to pause the video and note down everything, please do that. Otherwise, you will never understand that how did we prove it. Okay, so in given, please write a triangle ABC in which DE is parallel to BC. DE intersects AB and AC at points D and E respectively. We have to prove that AD upon DB is equal to AE upon EC. AD upon DB is equal to AE upon EC. Construction. We have to join BE and CD. We have to join BE and CD. Okay, after joining BE and CD with dotted lines, you have to draw EP perpendicular to AB. Do you see EP perpendicular to AB? Yes, and you have to draw DQ perpendicular to AC. Do you see DQ perpendicular to AC? DQ perpendicular to AC. Okay. Now let me take you towards the proof. Okay. Remember what we have to prove. We have been given that DE is parallel to BC. We have to prove that AD upon DB is equal to AE upon EC. Okay. We have done the construction. Now let's see how the proof will be. So I will keep the triangle over here so that we can all see it. Now let's start with the proof. So I'm all aware that I'm sure that you all are aware that how to write a proof. It must consist of a statement and the reason. If you have forgotten how to write a proof, then I think you might able to recollect while you see me writing right now. Okay, so the first thing. Now the first thing is let us find the area of triangle ADE. What is the area of triangle ADE? It is half into base into height. Okay, so what is the base of ADE? Now, since I have drawn perpendicular from E to point P, which is on AD, so if this is the perpendicular EP, I will consider AD as my base. And the perpendicular will become the height. Height will be EP, AD into EP. That is the area of triangle AD. Okay, then what is the area of triangle EDB? EDB. Can you see triangle EDB? This is triangle EDB. This is triangle EDB. Now this triangle EDB, its area is again half into base into height. Half into base into height. Okay. Now can you tell me what is the base of triangle EDB? Now, if you see, you must have a visualization because I cannot turn this figure and show you. You must visualize. Yeah, I might have some, very advanced animation techniques and, show it to you that, okay, this is the base. But I don't want to do that. I don't want to do that because if I do that, then you might not be able to visualize. Okay, so I might try it once for you that how to rotate this triangle. See, I'll take this triangle over here and let me rotate it like this. Still, it's not happening like how I want it. Yeah, but still, this ED becomes the base. Okay, I cannot rotate it like how I want it, but still. So let me rotate it back and put it back in its place and increase its size. Okay, so let's talk about it now. What is the base? Which is the base I'm talking about? BD. BD is the base I'm talking about. Okay, so base will be BD, and on BD, which is the height? Height is the perpendicular. Now, sometimes in some obtuse angle triangles, like you see an obtuse angle triangle like this, if I want to draw a perpendicular, let's say this obtuse angle triangle, this angle is D, this is E, and this is B. Okay, in this obtuse angle triangle, where will be a perpendicular on BD? It cannot be inside the triangle, so you draw the perpendicular outside the triangle, like this, and over here, right? So EP will be perpendicular, and perpendicular lies outside the triangle, but that doesn't matter, right? So you understood which is the perpendicular on triangle ABD's base BD. EP is the perpendicular. So again, I'm going to write EP. Okay. Now, what I want you to do is find the ratio of area of triangle ADE upon area of triangle EDB. See, area of triangle ADE upon area of triangle EDB is half into AD into EP, the whole upon half into BD into EP, right? The ratios, the areas which we got, we wrote them in the form of ratios, and now this half is going to get cut, This EP is going to get cut and we will be left with AD upon BD. AD upon BD. Okay, so we have got one ratio, AD upon BD. If you look closely, AD is here, and if you look closely, BD is over here. And what we had to prove, remember what we had to prove. We had to prove AD upon DB is equal to AE upon EC. Now just if we can prove AE upon EC to be equal to this our ratio which we have just got, then I think we are done. But how to do that? Now I want you to do a little visualization. See, we have taken these two triangles up to now. That is the red one and the green one. And these both triangles areas ratio we have found, and we have found them to be equal to AD upon DB. Now I want you to choose two more different triangles. So which two triangles will they be? They will be I'm going to delete this for a moment. Okay, so I will keep the red triangle. They will be ADE and let me use a black pen, DEC. ADE and DEC. Can you see the triangles now? Now, in the place of my other triangle, which I drew, the green one, okay, I just used, now I am drawing, I'm drawing the other triangle on the other side, on the right side. So that is DEC, opposite to BDE, okay, or EDB. Now, straight away, if I ask you, can you find area of triangle ADE upon area of triangle DEC? Can you find it directly in the ratio form? So, area of triangle ADE we already know. Okay, half into, okay, here you need to be little careful. Initially, for this triangle, we took AD as base. Now I want you to shift the base. Now make the base as AE. Okay, so base will be AE multiplied by height. Which perpendicular is drawn on AE? DQ. DQ. That's the only difference. Okay, upon area of triangle DEC. Now in triangle DEC, I want you to take the base as EC. So half into EC. Now on the base BC, on the base EC, the height is going to be DQ. DQ is going to be the height on the base EC. Okay, so here we are going to write DQ, since both the triangles have same height, that is DQ. So half will cut, DQ will be cut, and we will be getting AE upon EC. Great. So we have got what is equal to AD upon BD and what is equal to AE upon EC. But are these two ratios equal to each other? Are these two ratios equal to each other? That is the whole idea. Now, if you compare the numerators of these two ratios, see the numerator, area of triangle AD. Here also the numerator is area of triangle AD. But numerators are same, but what about the denominator? In the denominator of the first fraction, I have triangle EDB. In the denominator of second fraction, I have triangle DEC. So what about the denominator? So for denominator, I'm going to write area of triangle EDB is equal to area of triangle DEC. Area of triangle EDB is equal to area of triangle DEC. And I don't know how many of you will remember this, but this is from a chapter called areas of parallelograms, areas of parallelogram. Do you remember that chapter from class 9? Area theorems or area of parallelograms. And what is the theorem? You know that? See, these two lines are parallel. Remember. Why the green triangle and the black triangle? I will make the green triangle for you. Why do the green triangle and the black triangle have the same area? Because since they lie on the same base and between same parallels. Since they lie on the same base and between same parallels, triangle EDB and triangle EDC, they both lie on the same base. Which is their same base? DE. And between the same parallels, between which two same parallels these two triangles, the green and the black one, lie? DE, between DE and BC, right? And that's why their areas are equal. The areas of the two triangles are equal if they lie on the same base and between the same parallels. Do you remember this theorem from class 9? Yes. So you must agree that the area of these two denominators are also same. The numerator are the same triangle, so their areas has to be same. So these two fractions are same, right? Area of triangle EDB is equal to area of triangle DEC, that we have proved. So we can say that therefore area of triangle ADE upon area of triangle EDB is equal to area of triangle ADE upon area of triangle DEC. Okay, so area of triangle ADE upon EDB is equal to AD upon BD. Area of triangle ADE upon DEC is equal to AE upon EC. Correct? So AD upon BD is equal to AE upon EC. AD upon BD or DB is equal to AE upon EC. That is what we had to prove, and we have proved it successfully over here. Did you understand the whole proof? I have explained you very slowly, very nicely. I generally do not spend this much time for explaining this proof in physical class. Okay, but I am doing it that right now because I can understand that some people might take time to understand this whole proof, and this is so fundamental, BPT, basic proportionality theorem, that if we just um, you know prove it in a hurry, then you won't be able to use its applications easily. Okay, now few more results based on this BPT. So we have already proved AD upon DB is equal to AE upon EC in our proof right now. Now I'm just going to show you few more results which we can obtain from this. I will write, so imagine that I proved this over here. I will write adding 1 to both sides. So if I add 1 on both sides, what will happen? AD upon DB plus 1 will become AE upon EC plus 1. So this will give me AD plus DB upon DB is equal to AE plus EC upon EC. Okay, I took LCM. So what is AD plus DB? AB upon DB is equal to AC upon EC. So this is number 1. The whole side AB upon DB, that is this lower part, is equal to AC, the whole side upon EC, that is the lower part. Okay, one more thing we can do. Let me write it over here. So we had proved AD upon BD is equal to AE upon EC by BPT, basic proportionality theorem. Now taking reciprocals of both sides. Taking reciprocals of both sides, what do you get? BD upon AD is equal to EC upon AE. Correct? BD upon AD is equal to EC upon AE. Now, adding 1 to both sides. So, initially, what did we do? In the first result, we added 1 directly and we got AB upon DB is equal to AC upon EC. In the second result, I first took the reciprocal and then I added 1 to both the sides. Okay, so after adding 1, it will become BD by AD plus 1 is equal to EC by AE plus 1. No need to look in the figure again and again because this is like simple arithmetic. We are not using the figure or the geometry over here. But yeah, the result will be shown in the figure. I will show you that. So BD plus AD upon AD is equal to EC plus AE upon AE. So BD plus AD is AB upon AD and EC plus AE is AC upon AE. Now again you can take reciprocal. Taking reciprocal, you will get AD upon AB is equal to AE upon AC. AD upon AB is equal to AE upon AC. Now just look at this result in the figure. AD upon AB. AD is the small red part upon AB, the whole side on the left side. AE, the small part upon AC. Right? So the first result is AB upon DB is equal to AC upon EC. The second result is AD upon AB is equal to AE upon AC. That is the second result. There are few more results which you can prove with the help of some more operations on this final result. But yeah, if you are able to prove the main theorem, that is this one, then the first and the second you can say supplementary result based on basic proportionality theorem, then you are good to solve any of the given question. In some of the question, they also talk about the relationship between DE and BC. Okay, but we are not going to talk about that right now before understanding the similarity part. So right now, basic proportionality stands proved for us. We are going to go. Okay, so this is the proof of basic proportionality theorem which they have done, which is exactly how we have done and proved it. As I proved two more results, they have also proved the two more results by adding one and then by taking reciprocal and adding one. The same thing, the exactly same thing what I have showed you, two extra result, they have also proved it. Okay. So if you summarize the whole basic proportionality thing into you can say some important results. So there can be 6 important results. Let us understand these 6 important results. These results can be applied by stating that we are using BPT, basic proportionality theorem. These all results are derived indirectly or directly by using basic proportionality theorem. So they all are related with BPT. Okay, so it is very important to know these results. Let's study them. So first one is AD upon, I'm sorry for that. The first one is AD upon DB is equal to AE upon EC. AD upon DB is equal to AE upon EC. This is actually the BPT. This is derived by proving BPT. This is BPT itself. The second one is AB upon AD. AB upon AD is equal to AC upon AE. Actually, this is the reciprocal of that result we had got. The second one is this one. Okay, after that we'll come to this. dB upon AD, dB upon AD is equal to EC upon AE. So this is the reciprocal of BPT. If you reciprocal BPT, you get this. If you reciprocal BPT, you get this. Okay, after that they have written AB upon AD. AB upon AD. See, what we had proved was AD upon AB, which is over here, is equal to AE upon AC. That this is the reciprocal of that result. No problem. Then they have got AB upon DB is equal to AC upon EC. This is the first result which we proved, and this is the reciprocal of that result. DB upon AB is equal to EC upon AC. Now you might ask me that should we remember all these results which we have proved? I think you should remember the BPT one. Then you should remember this one. Let me just erase and highlight which ones to remember, otherwise you will get confused. You'll say so many results, how can we remember? We will get mixed up. So see, the first BPT is of course important. Then the second one you should remember is AD upon AB is equal to AE upon EC, and the third one which you remember is AB upon DB is equal to AC upon EC. That's it. If you remember these three results, that is what we have discussed when I proved the theorem for you. Okay, that much is more than enough for you to solve any numerical based on BPT. Okay, but yes, BPT does not only have numericals, it has proofs also, and the way we proved the theorem will help you a lot to prove the questions which are based on proof geometry. Okay, the next theorem is converse of BPT, converse of basic proportionality theorem. This theorem is rarely asked in exams. So this theorem is not much of an exam oriented theorem. Nonetheless, we are going to prove it. Okay. So what is this converse of basic proportionality theorem? See, converse of any theorem is generally the reverse of that theorem. Reverse means uh, if we have proved one thing in the original theorem, we are going to prove the same thing in reverse order. The thing which we have proved in the original theorem, we are going to take it as given, and the thing which was given in the original theorem, we are going to prove it in its converse. For example, in converse of basic proportionality theorem, if a line divides any two sides of a triangle in the same ratio, then the line must be parallel to the third side. So in this figure, as you can see, triangle ABC is divided by a line L. Do you see a line L which is cutting the triangle ABC? Don't look at the dotted line as of now. That's a distraction. That is actually a construction which we are going to do it later. But as of now, just focus on the line L which is cutting triangle ABC at point D and E respectively. So this line is dividing any two sides of the triangle. Two sides of the triangle are AB and AC. In the same ratio, they are dividing the two sides of the triangle in the same ratio. Then the line must be parallel to the third side. Then the line must be parallel to the third side. What do you mean by then the line must be parallel to the third side? This line which is dividing AB and AC in equal ratio, that is AD upon DB is equal to AE upon EC, that is known. Then this line must be parallel to the third side, that is DE must be parallel to BC. So you have to prove that DE is parallel to BC, and you have been given that AD upon DB is equal to AE upon EC. Remember, in the original basic proportionality theorem which we just proved, theorem number 1, in that they had given that DE is parallel to BC, and you had to prove AD upon DB is equal to AE upon EC. But here they have given AD upon DB is equal to AE upon EC, and you have to prove DE is parallel to BC. Correct? So how we will do that? Now see, before we begin with the construction which they have made, that is to be understood. So what you have to do, that you have to assume that there is a point F on side AC of triangle ABC, and we have to join point D with F such that DF is parallel to BC. So I will write the information which I just told you over here. Construction. Let F be a point on AC such that DF is parallel to BC. So we have considered a point F on AC such that when D and F are joined, it becomes parallel to BC. We assume that. Okay, so let means assumption. This is an assumption. Okay, now what will be the proof? Now, since DF is parallel to BC, we can say that AD upon DB is equal to AF upon FC, right? By basic proportionality theorem. We can use BPT, na? Did you understand what did I do? I said that let F be a point on AC such that when D and F are joined, it becomes parallel to BC. Now, DF is parallel to BC. So we can apply basic proportionality theorem. A parallel side drawn in a triangle to the third side divides the other two sides in equal ratio. So AD upon DB equals to AF upon FC by BPT. But we already know that AD upon DB is equal to AE upon EC. Correct? We already know this. Okay. So this is given. Okay. So see, in both the ratios, AD upon DB is there. So we can say that, therefore, AF upon FC is equal to AE upon EC. AF upon FC is equal to AE upon EC. Okay, now this is very, very peculiar. AF upon FC is equal to AE upon EC. Now the statement which is going to follow is very interesting, because they are going to show that F and E are not two different points. F and E are the same points. Only then AF upon FC can become AE upon EC. And see how they have written. Okay, okay, they have done one more thing. They have added 1 to both the side. Okay, let us also add. Maybe this becomes easier. So adding 1 to both the side, we get AF upon FC plus 1 is equal to AE upon EC plus 1. So we will get AF plus FC upon FC is equal to AE plus EC plus, sorry, AE upon EC, AE plus EC upon EC होना चाहिए, AE plus EC upon EC, which is AF plus FC is AC upon FC is equal to AE plus EC is AC upon EC. Now both the sides AC will cut, and therefore FC is equal to EC. Yes, so I think just comparing the ratio does not give you the full idea about what is equal to what. But yeah, adding 1 to it and simplifying it gives you a complete idea that FC is equal to EC. Now, do you think FC is equal to EC? F is a separate point. FC can never be equal to AC if it is a separate point. Okay, so you must write this statement like FC is equal to EC is possible only when F and E coincide. Therefore, if DF is parallel to BC, therefore we can say we can say if DF is parallel to BC, we can say that DE is also parallel to BC because F and E are coinciding. F और E तो एक ही पॉइंट है, तो अगर DF BC से पैरेलल है तो DE भी BC से पैरेलल होगा. तो थोड़ा कॉन्ट्राडिक्टरी मेथड है, थोड़ा इनडायरेक्ट मेथड है प्रूफ का. जनरली प्रूफ्स ऐसे होते नहीं है. जो भी अजम्पशन और ये जो कॉन्ट्राडिक्शन बेस्ड प्रूफ होते हैं, दे आर जनरली बीइंग अवॉइडेड इन द एग्जाम. एग्जाम में नहीं पूछते हैं. ये तुम्हें लॉजिकली इसको समझने की कोशिश करनी है जनरली, ठीक है. बट इसका जो मेथड है इसको याद रखना, क्योंकि हो सकता है कि इन क्वेश्चन कभी कोई क्वेश्चन ऐसा आ जाए तो जिसमें ऐसी मेथड हमें यूज करनी पड़ सकती है. हाँ, बट कन्वर्स ऑफ बीपीटी क्वेश्चंस में बार बार यूज होता है. दैट इज इफ द साइड्स आर डिवाइडेड प्रोपोर्शनली बाय एनी लाइन, then that line must be parallel to the third side of the triangle. ठीक है, तो इसका बार बार यूज होने वाला है. बट ये थ्योरम को प्रूव करने के लिए जनरली नहीं बोलेंगे, फिर भी हमने कर दिया है तो प्लीज नोट इट डाउन प्रॉपर्ली. ठीक है, एक बार ये मेरे थ्योरम्स का सारे थ्योरम्स जैसे ही मैंने कवर कर लिए, तो मैं क्या करूंगा कि मैं ये सारा ये जो पूरा पीडीएफ है जिसमें सारी थियरम्स नोटेड है एक साथ, वो मैं तुम्हें दे दूंगा. तो थियरम्स का एक अलग से तुम्हारे पास एक पीडीएफ बन जाएगा, फाइल आ जाएगी, तो उसको तुम स्टडी कर सकते हो थियरम्स को, और यू कैन टेक केयर ऑफ इट सेपरेटली. ठीक है, ओके. नाउ सी internal and external bisectors of a triangle. Now this is a separate theorem which is known as an angle bisector theorem. Angle bisector theorem, इसको भी हम prove करेंगे. I don't know whether this theorem is there in your NCERT or not, but अगर ये theorem तुम्हें पता है तो इसके ऊपर based कुछ थोड़े से difficult tricky questions है, वो इसके ऊपर based है जो तुम solve कर सकते हो. So I am going to cover it in my lecture. ठीक है, some people might feel that अरे ये तो है ही नहीं, बाकी के theorems important है, but let me tell you, BPT के बाद अगर ये theorem नहीं किया तो तुम्हारा जो पूरा कोर्स है वो incomplete है. ठीक है, so you must do this theorem. This is the third theorem. Let's do it. The first theorem is internal angle bisector theorem. इसको एंगल बाइसेक्टर थ्योरम भी बोलते हैं, इंटरनल एंगल बाइसेक्टर थ्योरम भी बोलते हैं. It says that the internal bisector of an angle of a triangle divides the opposite side internally in the ratio of the sides containing the angle. So before I explain you in this triangle, because it has got complicated construction, let me draw another triangle for you and let me show you what is the meaning of this theorem. So this is triangle ABC and AD is the angle bisector. So it says that bisector of an angle, internal bisector means bisector, the bisector which is bisecting internal angle. It divides the opposite sides internally in the ratio of the sides containing the angle. So it divides the opposite side. So which is the opposite side? Opposite side is BC. So BC side is being divided. How it is divided? BD upon DC. Okay, the ratio of this sides, the ratio of the sides which is being divided internally, okay, it is equal to the sides ratio of the sides containing the angle. The internal bisector of an angle bisector of a triangle divides the opposite sides internally in the ratio of the sides containing the angle. Okay, now the ratio of BD upon DC is equal to the ratio of the sides containing the angle. Which angle are we talking about? We are talking about angle A. And angle A is divided into AB upon AC. Angle A is contained in the sides AB upon AC, not divided. It is contained in the sides AB upon AB and AC. So the ratio of AB and AC is equal to the ratio of BD and DC. So what is BD and DC? BD and DC are the parts of the opposite side which is cut by the angle bisector. And the ratio of BD and DC is equal to AB upon AC. AB upon AC are the sides which contain the angle A. So BD upon DC is equal to AB upon AC. Great. We have to prove this. Okay, and for proving this, we will need to do some construction. So let's focus on the construction part. So this is the triangle ABC in which AD, which is the angle bisector of angle A, it meets BC at point D, and you have to prove that BD upon DC is equal to AB upon AC. You have to draw a line CE parallel to DA. CE parallel to DA. CE parallel to DA. Meeting BA produced in E. So you have to produce BA and let it meet CE at point E, and CE is drawn parallel to AD. Okay, so you understand the construction? Okay. Now I want you to look at this triangle in such a way that you can apply BPT in it. You have to apply BPT in this triangle. Okay, so I want you to look at this triangle in a horizontal way, like this. I'm drawing this figure just for your reference so that your visualization improves. This is B, D, C. This is B, A, E, and DE is the, sorry, AD is the angle bisector. I will join AC over here. This AD is the angle bisector. DA is drawn parallel to CE. Okay, so this is the case. I want you to visualize this triangle like this, like how I have drawn. Okay, now I'm going to write the proof. How do I prove BD upon DC is equal to AB upon AC? It is very easy. See, the first thing, how they have given the numbers to the angles, we can also give numbers to the angles. Okay, so this one, they have given number 1, we will also give number 1. This angle, they have given number 2, we will also give number 2. This is number 3 and this is number 4. Correct? Now see, the first thing is angle 1 is equal to angle 2. Can you tell me the reason why angle 1 is equal to angle 2? Since AD bisects angle A. Since AD bisects angle A, angle 1 is equal to angle 2. Next is angle 2 is equal to angle 3. Angle 2 is equal to angle 3. Why angle 2 and angle 3 are equal? Because since AD is parallel to CE. Since AD is parallel to CE, AD and CE are parallel, so 2 and 3 are which angle? Alternate interior angles are equal. Alternate interior angles are equal since AD is parallel to CE. Angle 2 is equal to angle 3. Okay. Okay. Also, angle 1 is equal to angle 4. Angle 1 is equal to angle 4. Can you tell me why angle 1 is equal to angle 4? Angle 1 is equal to angle 4 because they are corresponding angles. Do you see angle 1 and angle 4 are corresponding angles? Right? So angle 1 is equal to angle 4. Now looking at these three statements, angle 1 is equal to angle 2 since AD is the angle bisector of angle A. Angle 2 is equal to angle 3, alternate interior angles. Angle 1 is equal to angle 4, corresponding angles. See, 1 is equal to 2, 2 is equal to 3, and 1 is equal to 4. From all these three statements, I can simply say that, therefore, angle 3 is equal to angle 4. Okay, now since angle 3 is equal to angle 4, therefore, in triangle ACE, AC is equal to AE. Why AC is equal to AE? AC and AE are equal because angle 3 and angle 4 are equal. Sides opposite to equal angles. Sides opposite to equal angles are equal. Right? So since sides opposite to equal angles are equal, that therefore AC is equal to AE in triangle ACE. So can I mark AC is equal to AE over here? Yes, definitely AC is equal to AE. What next? The next thing which I'm going to write is in triangle BCE. Now look at this figure. You can also look at this figure, but this will be more easy for you. In triangle BCE, DA is parallel to CE by construction, right? DA is parallel to CE by construction. Therefore, you can say that BD upon DC is equal to BA upon AE. BD upon DC is equal to BA upon AE. Why? BPT, basic proportionality theorem. Right? Now, one thing I'm going to just change in this. I will keep BA as it is, but in place of AE, I will write AC because AE and AC are equal. So BD upon DC is equal to AB. In the place of BA, I am writing AB. There is no problem, no difference it makes. In place of AE, I will write AC because they are equal. I have already proved. And this is what I need to prove. See, BD upon DC is equal to AB upon AC. So this is the angle bisector theorem. Angle bisector theorem says that in a triangle, again I am telling you that don't be confused when you have to actually use it. Okay, suppose this is your triangle, and in your triangle, suppose you have this angle bisector. Let me name your triangle as PQR, and PS is the angle bisector. Then the ratio of the parts of the side which is divided by the angle bisector, that is QS upon QR, sorry, QS upon SR. QS upon SR is equal to the ratio of the sides containing the angle. So this angle P is contained by which two sides? PQ and PR. So PQ upon PR. QS upon SR is equal to PQ upon PR. That is your angle bisector theorem, and which you should be applying. This construction and all is just to prove this theorem. Although this theorem has not been asked in exam till date, but since we have used BPT for proving angle bisector theorem, it becomes important. There might be a question close to this theorem which can be asked in the exam. So you must study this theorem because it is one of the application of BPT. Okay, so we have proved it. Let's see what is next. So the next part is converse of basic proportionality theorem. I'm sorry, converse of angle bisector theorem. So in a triangle, if D is a point on BC such that BD upon DC is equal to AB upon AC, AD is the angle bisector of angle A. So let me take the same figure which I had taken, which I had drawn over here. Let me take it down. and let me just change the name. Okay, so in my question, the names are like this: triangle ABC, and AD is the angle bisector. And we have been given that BD upon DC is equal to AB upon AC. We have to prove that AD is the angle bisector. I'm sorry, it is not the angle bisector, but we have to prove it. Okay, so we have to prove that AD is the angle bisector, or angle BAD is equal to angle CAD. That's what we need to prove. Okay, so again, I think we have to do one construction, and in that construction, we will draw a line. In our construction, we'll draw a line. Okay, so this line is CE. Let's say this is CE, which is parallel to AD, and we have joined A to E. CE is parallel to AD, and we have joined A to E. Now remember what we have to prove. Okay, we have to prove that these two angles are equal. So let me name them. 1, 2. Let me name this angle as 3, and let me name this angle as 4. Okay, so just like before, everything is just like before. Now let me take this figure to the right side and prove this. Okay, so now we have a figure and we have ample of space to prove it. Let me write given. Given is in triangle ABC, BD upon DC is equal to AB upon AC. To prove AD bisects angle A, that is angle 1 is equal to angle 2. ठीक है, construction, draw same construction like we did earlier. Draw CE parallel to AD, draw CE parallel to AD, and produce AB to meet CE at E. Okay, we have produced AB up to E. Okay, now we are ready for the proof. Number 1, angle 2 is equal to angle 3. Why angle 2 is equal to angle 3? See, angle 2 is equal to angle 3 since they are alternate interior angles. Okay, angle 2 is equal to angle 3. Achha, what about angle 1? Angle 1 will be equal to angle 4. Why will angle 1 be equal to angle 4? Angle 1 will be equal to angle 4 because they are corresponding angles. Okay, one more thing we have been given, that is DE. Since DE is parallel to sorry, not DE, AD. Since AD is parallel to EC, since AD is parallel to EC, by construction, so we can say that BD upon DC is equal to BD upon DC is equal to BA upon AE. Okay, BD upon DC is equal to BA upon AE by BPT. Correct? BD upon DC is equal to BA upon AE. Just look at the figure whenever I am writing some statement. Look at the figure and try to figure out कि मैं क्या लिख रहा हूँ. ठीक है, नहीं तो confuse हो जाओगे. Okay, but we know that BD upon DC is equal to AB upon AC, which is given to us. BD upon DC तो AB upon AC से equal है, and therefore we can say that BA upon AE is equal to AB upon AC. जब BA और AB तो कट जाएगा, right? AE is equal to AC हो जाएगा, therefore AE is equal to AC. ध्यान से देखो फिगर में AE is over here, AC is over here, and therefore we can say that angle 3 is equal to angle 4. Angle 3 और angle 4 equal क्यों है? Angles opposite to equal sides. Angles opposite to equal sides. लेकिन एक बात ध्यान दो, मैंने यहां पे अभी प्रूव किया था कि एंगल 1 इज इक्वल टू एंगल 4. अब मैंने क्या प्रूव किया? एंगल 3 इज इक्वल टू एंगल 4. तो देयरफॉर मैं लिख सकता हूं, देयरफॉर एंगल 1 इज इक्वल टू 4 है, 3 इज इक्वल टू 4 है, तो और 2 इज इक्वल टू 3 है, 2 इज इक्वल टू 3 है, तो मैं सीधा सीधा लिख सकता हूं देयरफॉर एंगल 1 इज इक्वल टू एंगल 2. देखो 2 इज इक्वल टू 3 है, 3 इज इक्वल टू 4 है, और 4 इज इक्वल टू 1 है, सो डेफिनेटली 1 और 2 भी इक्वल होंगे. ठीक है, अगर एंगल 1 और 2 इक्वल है, देयरफॉर एडी इज द angle bisector. AD is the angle bisector of angle A. ठीक है, so this is how you prove the converse of angle bisector theorem, and here also you have used BPT. Here also you have used BPT. Okay, this next theorem is external angle bisector theorem. It says that the statement, the external bisector of an angle of a triangle divides the opposite side externally in the ratio of the sides containing the angle. The external bisector of an angle of a triangle divides the opposite sides externally in the ratio of the sides containing the angle. So in triangle ABC, AD is bisector of exterior angle A. Do you see AD? AD bisects exterior angle A. Which is the exterior angle A? Angle CAP. So this CAP is bisected by AD. That is angle 1 is equal to angle 2. Intersecting BC produced in D. So BC is produced to D. Okay? So this is how the figure looks like. You have to prove that BD upon CD. Remember, BD upon CD is equal to AB upon AC. AB upon AC. Now, AB and AC are the sides containing the exterior angle as well. ठीक है, तुम सोचोगे कि जो एंगल एक्सटीरियर है उनका AB और AC से क्या लेना देना, तो AB और AC आर द साइड्स कंटेनिंग द एक्सटीरियर एंगल. ठीक है, द रेशियो ऑफ AB एंड AC इज इक्वल टू द रेशियो ऑफ BD अपॉन CD. The external bisector of an angle of a triangle divides the opposite side externally. Opposite side, ये जो एंगल A है उसकी opposite side कौन सी है? BC. और BC को externally कैसे divide करेंगे? BD upon BC. Sorry, BD upon CD. So BD upon CD is equal to AB upon AC. That is what you need to do. And here they have done one construction. The construction is drawing CE. parallel to AD. They don't look like parallel, but yeah, they have drawn it parallel. ठीक है, तो ये पैरेलल है ऐसा मान लो. ठीक है, अब इसको कैसे यूज करके वी विल प्रूव दैट ए बी अपॉन ए सी इज इक्वल टू बी डी अपॉन सी डी. लेट्स सी. नाउ वी नो दैट AD is the external bisector. तो एंगल 1 इज इक्वल टू एंगल 2 तो होने ही वाला है. एंगल 1 इज इक्वल टू एंगल 2. अच्छा, दूसरी बात ये है कि CE is parallel to AD. CE is parallel to AD, right? So angle 4 is equal to angle 2 भी होने वाला है. एंगल 4 is equal to एंगल 2 हो सकता है, करस्पॉन्डिंग एंगल. और क्या हो सकता है? ये तो लग रहा है मुझे करस्पॉन्डिंग एंगल है डेफिनेटली. 4 और 1 और 2 इक्वल है. 4 और 2 करस्पॉन्डिंग एंगल्स है. आई थिंक ये AD को थोड़ा सा अगर हम P के साइड शिफ्ट कर देते तो पैरेलल दिखता है, एंड देन 4 और 2 इक्वल दिखता है. तो 4 और 1 और 2 तो इक्वल है. व्हाट अबाउट angle 3, because there is no relation of angle 3 given anywhere. ठीक है, एंगल 3 के बारे में तो हमें कुछ पता नहीं. Let's apply BPT. Yeah, we are not applying that. ठीक है, इससे आगे तो एंगल का कुछ रिलेशन समझ में नहीं आ रहा. लेट्स अप्लाई BPT. So BPT says that BE upon AE is equal to BC upon CD. BC upon CD. हमको क्या चाहिए? BD upon CD. और हमको क्या मिल रहा है? BC upon CD. तो why not add 1 to both the sides? तो BE by AE plus 1 is equal to, ये तो BPT है, right? Because of BPT we are getting this. BE by AE plus 1 is equal to BC by CD plus 1. So what is BE by AE plus 1? What is BE plus AE? BE plus AE will be AB. AB by AE is equal to BC by CD plus 1. That is BC plus CD, which is BD. BC plus CD is BD by CD. BD by CD. So AB by AE is equal to BD by CD. ठीक है, we have to prove AB by AC. So somehow if we prove AE is equal to AC, AE is equal to AC, right? So if you see over here BD by CD and AB, yes, we have to prove AE equals to AC. Now please be little patient over here, because I know that you might think that ये तो है भी नहीं हमारे सिलेबस में, क्यों इतना ज़्यादा टाइम वेस्ट कर रहे हो. अगर तुम्हें ऐसा लगता है तुम वीडियो को आगे स्किप कर सकते हो, बिंदास. ठीक है, कोई कंपल्शन नहीं है तुम्हें देखने के लिए. मैं तो ये करूँगा ही. ठीक है, ये एक्सटीरियर एंगल है, ये बाइसेक्टर है उसका. एक्चुअली ये पूरा एक्सटीरियर एंगल है. यहाँ पे है A, यहाँ पे है B, यहाँ पे है D, यहाँ पे है C, यहाँ पे है P. अच्छा, यहाँ से मुझे एक लाइन बनानी है which is parallel. Now in this figure, does it look like A is equal to AC? इट डज राइट। ए ई और ए सी इक्वल है क्या? अच्छा, ए ई और ए सी को इक्वल होने के लिए ये नंबर 4 है, ये नंबर 3 है, ये नंबर 1 है, ये नंबर 2 है, ये वाला एंगल और ये 4 वाला एंगल इक्वल होना चाहिए। सो व्हाट इज दिस एंगल इक्वल टू? इसका क्या रिलेशन हमारे ट्राइंगल में? लेट्स थिंक अबाउट दैट। Yes, I think I got the relationship. I got the relationship. Be carefully attentive about what I'm going to say now, because this is going to blow your mind. ठीक है, अभी देखो, what did I tell you that angle 4 is equal to angle 2? मैंने बताया तुमको, ठीक है। नाउ एंगल 1 प्लस एंगल 2, ये लोग ने जो एंगल 3 यहाँ पे लिखा है ना, मुझे ये गलत लग रहा है। एक्चुअली ये एंगल 3 यहाँ पे होना चाहिए, इसकी कोई ज़रूरत नहीं है, ठीक है। सो मैं एक मोमेंट के लिए यहाँ पे थोड़ा जगह बनाता हूँ, इसको मैं नंबर 3 लेता हूँ और फिर इधर छोटा सा एरो बनाता हूँ, जस्ट टू से दैट दे आर पैरेलल, ठीक है। अब देखो, एंगल 1 प्लस एंगल 2 इज इक्वल टू एंगल 4 प्लस एंगल 3। एंगल 4 प्लस एंगल 3 क्या है? एंगल 1 प्लस एंगल 2। क्यों? एंगल 1 प्लस एंगल 2 पूरा देखो क्या है, इट इज एन एक्सटीरियर एंगल फॉर ट्राइंगल AEC। डू यू सी ट्राइंगल AEC? ट्राइंगल AEC का एक्सटीरियर एंगल एंगल 1 प्लस एंगल 2 है, बट एंगल 1 और एंगल 2 तो इक्वल है। तो क्या मैं इसको लिख सकता हूँ 2 टाइम्स एंगल 2 इज इक्वल टू एंगल 4 प्लस एंगल 3? बट एंगल 4 तो एंगल 2 से इक्वल है, तो क्या मैं इधर लिख सकता हूं 2 टाइम्स एंगल 4 इज इक्वल टू एंगल 4 प्लस एंगल 3? फिर क्या मैं लिख सकता हूं 2 टाइम्स एंगल 4 माइनस एंगल 4 इज इक्वल टू एंगल 3, रूट 3 लिख रहा हूं, एंगल 3, ठीक है। विच इंप्लाइज दैट एंगल 4 इज इक्वल टू एंगल 3, विच इंप्लाइज दैट AE इज इक्वल टू AC। प्रूव कर दिया ए इज इक्वल टू ए सी। तो ये पूरा जो थियरम हमने बीपीटी से बनाया था, इट कैन बी नाउ रिटन एज ए बी अपॉन ए सी इज इक्वल टू बी डी अपॉन सी डी। ए बी अपॉन ए सी इज इक्वल टू बी डी अपॉन सी डी, यही हमें प्रूव करना था, ठीक है। समझ में आया कैसे प्रूव किया है? नहीं समझ में आया तो फिर से देखो ये वीडियो को, या फिर ये जो प्रूफ है इसको फिर से देखो, ठीक है। अगर प्रूफ से तुम्हें समझ में आता है तो बहुत अच्छी बात है, नहीं तो मैंने जो तुम्हें कमेंट्री दी है वीडियो में उससे समझने की कोशिश करो। ये पूरे प्रूफ का तुम वीडियो पॉज करके लिख सकते हो इसको, बट ये पूरे प्रूफ का जो सारे थियरम्स का जो PDF है वो मैं तुम्हारे साथ शेयर कर दूंगा, सो यू डोंट नीड टू वरी, ओके। More applications on basic proportionality theorem. Already 1.5 hour is closing up. I don't want to make this video more longer. I think I underestimated the number of proofs and the time which I'm taking it to explain. So I'm taking more time to explain the proofs, and that's not a problem. I don't think that's a problem. That's a good thing that I could explain it by taking more time. सो और एक वीडियो मुझे लगता है मुझे बनाना पड़ेगा, एंड मे बी द सेम लेंथ 1.5 hour, जिसमें ये सारे प्रूफ्स मैं कवर करूंगा, ठीक है। तो ये सारे प्रूफ जो बाकी के बचे हुए प्रूफ है अभी, वो कवर करने के बाद फिर हम लोग सॉल्ड एग्जाम्पल पे जाएंगे। सो इट्स गोइंग टू टेक अ लॉन्ग टाइम। आई होप यू आर प्रिपेयर्ड फॉर इट। आई होप यू आर नॉट कंप्लेनिंग के बहुत टाइम लग रहा है, ये वो जो भी है, अब जो है उससे तुम्हें एडजस्ट करना पड़ेगा, ठीक है। And you should be thankful and grateful that I'm taking my time and I'm teaching you in detail. Otherwise लाइव क्लास में तो इतना टाइम नहीं मिलता है, ठीक है। लाइव क्लास में फटाफट हमको भागना पड़ता है, ये सारे थियरम्स हम डिटेल में नहीं पढ़ सकते हैं और बच्चों के डाउट रह जाता है। नाउ इट इज़ ऑन रिकॉर्ड, you can go through the theorems all over again to understand if you have got the basic concepts cleared or not, ठीक है। और जिनकी एग्जाम्स आ रही है, जिसको ये चैप्टर आने वाला है, वो भी थियरम्स को अच्छी तरीके से कर सकते हैं, सो दैट द एप्लीकेशन विच वी आर गोइंग टू डू इन द नेक्स्ट वीडियो, नेक्स्ट टू नेक्स्ट वीडियो, जो उसके ऊपर क्वेश्चंस है वो भी तुम अच्छे से सॉल्व कर। ठीक है। सो मोर एप्लीकेशंस ऑन बेसिक प्रोपोर्शनैलिटी थियरम and the remaining theorems which I had discussed will be done in the next video. See you in the next video. Bye bye.